And I added at some point something that we're going to put on the stack. And again, in this class, it really doesn't matter what sorts of things we're dumping on and off into this storage facility. So any object will do for testing to see whether or not you can put it on or off the stack. So I just stole the worker class from a previous lab or whatever it was. Okay? So let's write what we think we'd want to put in a stack class. And in this case, I'm not even going to write a stack class. I'm going to talk about stacks in general. So, suppose we've got this pile of things. What are the kinds of things that we can ask the pile to do for us?
Add something or remove it.
Add something to the pile. So what's the stack terminology for that? Push. So if we wanted to talk to it, if this is an interface, what we would write is public void. You want to say add, but it's actually going to be push, to use the old stack terminology. What are you going to give it?
You're going to give it a string or
When you say object, you're saying it could be anything. Could be a worker object, could be a student object, could be a newspaper object that you're pushing onto this stack, could be a URL. It doesn't really matter. That was the old terminology. The newest thing that we just did is we said, well, we'll use a variable in place of this and we'll call it E. And so we'll put the angle brackets on there to say that thing's going to be an E-type thing. And if I'm lucky, I got that right. Oh, okay. Instead of a class, this needs to be an interface. That will make me happier. So not writing the actual class, I'm just thinking of the things you could say to a stack. Okay? So the rule here is if I make a new stack, then if it's a stack of student, just substitute E becomes student, and I'm saying push a student onto the list. So it just becomes sort of a more specific thing than object. What else could we ask our stack to do?
one pop first item.
Go get the thing back. So that's public, pop. What arguments do you give pop? What does it give back? Gives back whatever you put on. If you put a student on the stack, you get a student back.
Is that E just an agreed upon letter, or does it actually stand for something?
E in this case, the way that you'll see it quite often is it could be any letter. They choose to use a capital letter to make it stand out. They choose to make it look sort of like a single variable letter, so more the mathy type thing rather than a big long name. And for the types of containers that we're using, you either see it as E for element or T for type. They avoid I for item because I looks too much like a 1. Okay, so E just sort of stands out. Okay, so, and I like, quite often you'll see it as T for type, but that just confuses students. So E sounds, an element sounds like an actual physical thing. A type sounds like this abstract thing to me. So that's why I'm using E.
Would it work if you change it to object throughout the whole thing, like even the top?
No, you can't. You can't make that change because object is a keyword and it won't work there.
Gotcha.
So it has to look like that. Okay, those are the two basics for things that you would put in a stack, and a stack really isn't particularly smart, so that's about all that it does, with one exception. What's the other interesting thing that you might want to know? Size. And the reason you typically want to know size is because at some point, if the thing is empty or you've popped off a bunch of stuff, you don't want to try to pop something that isn't there because that would be an error. So usually these things will have a public int size method also. Now you can add extra stuff. we could add things that you could actually go take a quick look inside to see what's going on without disturbing it. But let's just leave it as the simplest thing that we can do, the most restrictive thing that we can do, and we'll worry about maybe changing this interface to reduce some of the restrictions later. Okay, so that's just the idea. If I were a stack, what kinds of things could you ask me to do? Okay, so those are just the words. We don't have a stack yet. So now let's go write a class that actually does what this promises to do. And let's write it with an array underneath. And so I'm going to call my new class stack, and I'm going to use the terminology to just run the two words together to say this has somehow got an array that we're going to use underneath to do the work of making a stack. Okay. Now, if I want it to do all of those lovely things that a stack does, make that promise, then what I have to say is implements stack interface. And that says I want to do that stuff. And the other thing that we're going to do is we're going to add on the E stuff in both places to say it's a restricted form of stack that will only allow you to put specific items on, whatever the restriction happens to be. And as soon as you do that, the complaint is you promised, but you're not doing what you say you're supposed to do. And so what we'll do is we'll add all of the methods that we're supposed to write, just put the method stubs in to do the work. Okay, so at this point, just so that we can get a sense of how this thing works, it never hurts to turn around and just write a main program. Just try it out. And so what I'm going to do, even before I get to unit tests, just so I can get some sense of how this works, is I'm going to write a little main program and see whether I know how to use a stack, even though it's completely broken. So to actually use the stack, I might do something like this, stack array that can only hold workers is a new stack array. So notice it looks essentially just like the way we used array list, except it's a little bit more restrictive. A new stack array that can only hold workers, constructor. And now I would do a stack dot push. And notice, by the way, just take a quick look at what Eclipse did there. Notice what Eclipse did when you say push. It's recognized from the definition of the restriction that I had on the previous line. Eclipse has already picked up the fact that the only thing that you can push onto the stack is workers. And if you try to push anything else because of the angle brackets, it's going to specifically warn you and go, that's not a worker. Okay, so it doesn't say object there, it doesn't say E there, it says worker, because that's what we told it could only be on the stack. So we can do a stack dot push some new worker. Really doesn't matter what this thing says. I think it takes 2 parameters. Don't really care. And then we could push something else on. And then we could say, let's just print out the size. And if we wanted to, we could pop something off and put it into a variable. And who would we expect that to be?
The top one,
Specifically who?
A.
Wouldn't it be B?
would be B, because we put A as yesterday's newspaper, B as today's newspaper on top of the stack. If you pull it off, you get today's newspaper. So you get the most recent thing that you just put on. So if we print out who dot, whatever it is, I guess all I have is a 2-string. We expect it to be B. So we can always write a unit test for that later once we sort of visually know that it works. Okay, so there's a sample of how we would use it, but we've got no code that actually keeps track of things yet. So what sort of variables are you going to need there if we're doing this with an array? Need an array. Can't use array list because we're trying to do things with arrays directly. So that would be an E array of all items to hold the array. And again, E just becomes worker. Well, I guess then we need a constructor to initialize that thing. What should all items be initialized to? So far we've got one variable. Should do it this way. So far we've got one variable, so this is, let's do it that way.
Is that weird? Not the box?
Yeah.
I can't do it.
What are we going to initialize all items to? What's going to be our storage facility? An array. So we're going to need some number of places to store the variables. How many do you want?
200.
Again, here's this problem with arrays, is that when you go to make a new E array of things, you're stuck inside there with having to put a number in there. Because we're back to the same thing as high school lockers. You have to go down to the office and say, this is how many I want. Pick a number, it's not going to matter for our purposes. We could put 20 in there. What's wrong with this line? What did we say it doesn't like?
Create the generic array of E.
There's a specific little trick for this one. This is that weird Java syntax thing. Yeah, you have to make it, just the syntax says, I don't know what an E thing is, I don't know how big it is. It does know how big what an object is. So at this point you can say new object array. I can hit the space bar. And then do a cast to say, no, really, I'm going to use that array of generic things to hold E things. It's a stupid little Java syntax thing. Suppose that, okay, so now that we've got our array of things, let's do the easy one. Suppose somebody says, how many things have you got? In general.
All items can't do dot size, so I'll just keep it 20.
Yeah, you can't do all items dot length because you don't have any. That's just how much room you have in the warehouse, basically.
You need a variable to keep track.
Need a variable to keep track of how many things do I have there. So we'll call it item count for a start. The other way is you could go through and you could see whether the array items are null or not null, but we'll just turn around and always keep track of them. So that means we need private int item count. What value should item count have to start with?
0.
Anything interesting about the item count variable besides the fact that it's counting how many items there are?
It's always gonna be tied to having.
It's always tied to what position in the array do I want to fill. So it's sort of serving two purposes. And so the question is, do you want to think of it in terms of how many things do I want to have I got? Or do you want to think of it in terms of where's the next place I could put something? You can try it either way. In general, you're worried about where you're going to put them and not how many you have. And so this is the one that I'm going to change. Instead of keeping track of the size, I'm going to keep track of it in terms of next empty position. So there's actually two different concepts in the same variable. Well, now that's easy because size still returns next empty position. That's fine. Just changed how we think about it. What happens when somebody says, I want you to push something into this array?
Next empty position.
We've now got all items and next empty. Where do you want to put it?
Next empty spot.
Yeah. The easiest way, by the way, when you see problems like this, if you're ever confused and you're staring at this empty blank slate trying to figure out, I don't know what I'm supposed to do with it, pretend that you've got some items there already and ask yourself the question, where would I put it? And then the answer becomes, well, I'd have to put it in the next empty position. And it becomes more obvious when you've got a few of them in there that the place where you want to put this thing is all items sub next empty position needs to hold on to whatever we were given. Suppose I put it there. What happens to next empty position?
You wanna add it afterwards?
It needs to move one downwards. Does this start to sound like object list? It should, because it's exactly the same thing we did for object list. It's just that it's a more restrictive way of handling an array. So it's gonna be almost exactly the same code, next empty position goes up by one. But notice that the reason for writing this is that push ties the action of those two variables together. Anytime you change the array, you're changing all items that go together. How about pop? What's Pfeiffer's rule for writing things that return values? Writing code that returns values, what's the first thing you should do? Make a variable that says, here's the one I'm interested in. What's the item that I'm interested in? If somebody says pop. The last one. Where can I find the last one?
Next empty position.
The only variable that we have is next empty position, which refers to that one.
Minus one.
So the one that's actually the last full slot is the one before the next empty position. Now, if you want to be a sneaky coder, what I would do for this, just to make things clear to people, is I would actually say last full position equals next empty slot minus one. Next empty position. Should have used a smaller word. Because then when I write this statement, it becomes item to return is at all items sub last full position. Okay? So just putting that word in there makes it really obvious that I'm looking for a position that was there, not one that wasn't there. Now I can send that thing back. And then I can go into the middle and ask myself the question, is there anything else I need to fix? Rule is, if I change the all items array, then I should look at this other variable. Oh, look, next empty position has to change too. It should actually decrement by 1. And just to be completely technically correct, after you've removed this one, then that last full position should now have nothing in it. And so it's not just a matter of removing it and saying, here's the one I want to give back. It's a matter of actually erasing the phone number from there so that there's nothing in there at all. So that you don't reuse it. In actual fact, you're not going to reuse it probably. You're going to write something over top of it. But just from a cleanup point of view, that's physically scrolling them out of the phone book. Okay. There's the complete implementation of a stack that uses an array underneath. So tomorrow what we're going to do is we're going to test it by writing the unit test to make sure it works properly. Once we've got it working properly with an array underneath, we're going to write the chained list version that does exactly the same sort of thing, and then we'll be able to reuse the unit test to see whether or not it works on our chained list version also.